All right, so today we're working on inequalities involving polynomials and rational functions. So our first example, we're asked to solve an inequality, but we're given the graph. So we're given the graph of negative x cubed plus x squared plus 6x, and we just want to find out when it's greater than 0. So what are we going to do? Well, when a function is greater than 0, that means its graph lies above the x-axis. So we're looking for all points x where the function lies above the x-axis. And we have a strict inequality, so we're not going to be including endpoints at all. So we're looking at all x from negative infinity all the way up to negative 2, open, and then from 0 to 3. Right? So we can write that in interval notation. Typically that's the easiest way to write these sets. So we're going to go from negative infinity to negative 2, open, union 0 to 3, open. And that's our answer. So when we're given a graph, these aren't too bad. Let's try another one. So now we're asked to find all points x where x squared plus x minus 2 is less than or equal to 0. So that means that we're looking for all the points where the graph lies below the x-axis. And in this case, we do have equality. That's what that line there means. So we are looking for the endpoints as well. So you can see we start hitting the x-axis at negative 2, and then we're below the x-axis right up until 1. Right? So our answer is going to be the interval from negative 2 to 1 closed. And again, we're closed because we are looking for the points where we're less than or equal to 0. All right, one more, because there is a little bit of a subtlety here. So here we're given another cubic, and we want to know when we're greater than or equal to 0. So we want to know when we are at the x-axis or above the x-axis. Now, because we have equality here, we're also including all points where we're on the x-axis. So as before, we're going to take the points from 1 to infinity, because that's where our function is above the x-axis, and we're going to include the endpoint. But we also need to include the point negative 2, because we are equal to 0 there. We touch the x-axis. That means we're equal to 0. So our answer is going to be 1 to infinity, open, union, the set containing negative 2. All right? So there we go. In the next video, we're going to work on doing this without the graph.